If you light a lamp for someone else, it will also brighten your path. Have you ever wondered the importance of car indicators? The big red light at the back of your car lights up the environment and gives an indication to the other cars that the car in front is about to stop. Isn't it a wonderful way to avoid accidents? Similarly, a blinking orange light on either side of your car warns the other drivers of your intention to take a deviation to any side. Here, the indication lights act as an effective means of communication between the drivers. But have you ever wondered how these lights blink in a certain sequence? You might have been to parties or celebrations at some part of your life. There you must have noticed the lights blinking in a certain sequence. So in today's session, let's learn how to make the LEDs blink using Arduino. In the previous session, we learned to turn the LED on using Arduino. So in this session, let's make the LEDs blink and also create different beautiful color patterns using LEDs. Are you excited? Well, let's get started. First, let's connect 3 LEDs and try to on it using Arduino Uno. Drag and drop the Arduino from the component library like this. And now, select an LED from the component library. Then place it in the workspace. And then select the second LED from the component library. Then place it in the workspace. Similarly, select the third LED from the component library and then place it in the workspace. Click on the first LED and we can name it as LED 1. And for a change, let's make the color of the LED to green. Click on the second LED and we can name it as LED 2 and change the color of LED 2 to green. Finally, click on the third LED and let's name it LED 3 and then change the color to green. Now we are going to turn the 3 LEDs on. So let's begin with the connections. First, change the wire color to red and then connect anode of the LEDs to the Arduino. Connect the anode of LED 1 to pin D2, the anode of LED 2 to pin D4 and the anode of LED 3 to pin D6. We have finished the positive connections. Now let's start with the negative connection. Change the wire color to black and connect the cathode of LED 1 to pin D3, cathode of LED 2 to pin D5 and cathode of LED 3 to pin D7. Okay, have you all finished it up to this place? Here we have connected the LEDs to the digital pins of the Arduino. If I turn it on right now, will it work? No, the LEDs will only work if we do coding to set the digital pins to high or low. Let's do the coding to turn these LEDs on. For that, click on Code. As always, you can see some blocks are present here by default. Just remove them. Here we are using 3 LEDs which are connected to 6 digital pins of the Arduino. So we require 6 set pin blocks. Let's drag and drop 6 set pin blocks. Here we connected the LEDs to pins D2, D3, D4, D5, D6 and D7. As the pins D2, D4 and D6 are connected to the positive leg of the LED, we need to set these set pin blocks to high. Similarly, the pins D3, D5 and D7 are connected to the cathode of the LED. So we need to set these pins to low. So let's change D2 to high, D3 to low, D4 to high, D5 to low, D6 to high, and finally D7 to low. Click on Start Simulation. and the LEDs are on. You did it! So now you are an expert in turning an LED on by programming. But to make the LEDs blink, we should be aware of turning the LEDs on as well as off. Don't worry, we can find a way to turn the LED off. Click on Stop Simulation. First, let's make the first LED, that is LED 1, off. So click on Code and let's remove these codes. To turn LED 1 off, we only need two set pin blocks, as LED 1 is only connected to the digital pins D2 and D3. We have already connected the anode of LED 1 to D2 and the cathode of LED 1 to D3. To turn the LED 1 on, we have to set pin 2 to high and pin 3 to low. Click on Start Simulation. See, now our LED 1 is the only LED which is turned on and the other LEDs are off. This is because we haven't programmed our controller to turn them on. Click on Stop Simulation. In order to turn on an LED, there is only one condition, that is, the positive terminal should receive positive and the negative terminal should receive negative. But to turn them off, we have three conditions. Condition 1. Set both the pins to low. That is, set pin D2 to low, set pin D3 to low. Here, both pins receive negative and the LED will not turn on. Condition 2. Set both the pins to high. That is, set pin D2 to high, set pin D3 to high. Here, both pins receive positive and the LEDs will not turn on. Condition 3. Set the pin where cathode of the LED connected to high and the pin where anode of the LED connected to low. Set pin D2 to low, set pin D3 to high. Here pin 2 receives negative and pin 3 receives positive, which makes the LED off. Let's try out one of these conditions. As per the first condition, give negative to both pins. That is, set pin D2 and pin D3 to low. Click on Start Simulation and you can see that LED 1 is off. This is because here both the pins receive negative power. But you may have noticed the LED 2 and LED 3 are also in off condition. This is because we haven't programmed to turn on these LEDs, so they will remain off until we code it to turn it on. Click on Stop Simulation. Earlier in this session, we talked about vehicle indicators. The mechanism behind it is very simple. The light remains on for some time and then it turns off. When this process works continuously, we feel the blinking effect. So similarly, we can make our LEDs blink. That is, we just only need to turn the LED on and off. Now let's make the LEDs blink. For that, first we can make LED 1 blink. Going to the coding part, set pin D2 to high and pin D3 to low, as the positive terminal should receive positive and the negative terminal should receive negative. Now the LED 1 will turn on, right? As we need to make the LED off, we need two more set pin blocks. So let's duplicate these two set pin blocks so that you don't have to drag it again to the coding space. For that, right-click on the blocks and then click Duplicate and place them below the first. Then we can set pin D2 and pin D3 to low. Click on Start Simulation and you can see that the LED is partially on, but it is not blinking actually. Can you guess the reason for this? This is because the on and off switching of the LED takes place in a fraction of milliseconds. That is, it would turn on and off thousands of times within a second, which the human eye is not able to capture. Oh, you know who it is? Hey Mr. X, What do you have to say? Did you know the inability of the human brain to perceive more than 2 images formed on the retina within an interval of 1/16 of a second? This is known as persistence of vision. Thank you, Mr. X. That was very valuable. I hope you understood about the persistence of vision. So we need to add a delay to give enough time to our eyes to capture the turning on and off of the LED. So click on Control block and select the Wait 1 sec block. We need to add the Wait 1 sec block between these codings to turn the LED on and off so that it can be visible to our human eye. Adding Wait 1 sec will make the LED 1 remain turned on for a second, and then it will remain turned off for another second. Now click on Start Simulation and the LED is on for a second and then is off for a second. See, we have successfully designed a circuit to make the LED 1 blink. Click on Stop Simulation. Here we have set the delay to 1 second. You can also increase or decrease the delay time. What will happen if we adjust the delay time? Let's take a look into it. Set the delay time to 0.5 seconds. Then click on Start Simulation and you can see the LEDs blinking faster. Here the LED is on for 0.5 seconds and then is off for 0.5 seconds. Click on Stop Simulation. By varying the delay time, we can reduce or increase the time for switching on and off the LED and make our LED blink slower and faster. You can also see that these codes are executed in a cyclic manner. That is, the LED will turn on for some time, then off for some time, and this process repeats. So we can say that these codes are executed by Arduino in a loop or in a cyclic manner. Now let's make the first and second LED blink. For that, let's duplicate the entire code blocks and place it below the first. Here we only need to change the pin number of the set pin blocks. To make the LED 2 on, change the pin number in set pin blocks to 4 and 5. Then make the pin D4 to high and pin D3 to low. Then to turn LED 2 off, the pins D4 and D5 have to be set to low. Click on Start Simulation and now you can see that both LEDs are turning on and off one after another. I hope you understood why I said this happens in a cyclic manner. That is, first the LED 1 turns on, then it is turned off, after that the LED 2 turns on and then turns off. And this happens in a cyclic manner. Click on Stop Simulation. Now let's do coding to make LED 1, LED 2 and LED 3 blink. Let's duplicate the entire code blocks and place it below the first and second blocks. Here we only need to change the number of the set pin blocks to D6 and D7. Click on Start Simulation. You can see that the first LED, LED 1 blinks, then the second LED, LED 2 blinks, and after that, the third LED, LED 3 is blinking. You can see LED 1, LED 2 and LED 3 blinks according to the code we designed. That is why we say we have to do coding based on our desired output. Now you can change the codings and create any blinking pattern of your choice. Click on Stop Simulation. Have you noticed the serial lights that we use for decoration purposes? Yes, it consists of many LEDs. They also blink and make different color patterns exactly like our projects. Isn't it simple to create patterns for the LED blinking? Just remember one thing. All you need is to set the codes according to our desired pattern and let the show begin. Let me show you an example of a different pattern. Go to Codes, set pin D2 to high and D3 to low, so that LED 1 will turn on. Then without making the LED 1 off, let's change the pin number to 4. Then change the pin number to 5 and set it to low. And set it to high. And now let's make the LED 2 on. So here LED 1 turns on and then LED 2 turns on. Then let's change the pin number to 6 and 7. And then set pin D6 to high and pin D7 to low. Now the LED 3 is on. So here is what happens. First LED 1 turns on. Then the second LED 2 turns on. And finally LED 3 turns on. Now we need to turn all the LEDs off. So change the pin number to 2 and 3. And then set pins D2 and D3 to low. Then change the pin number to 4 and 5. And set the pins D4 and D5 to low. Then change the pin number to 6 and 7. And the pins D6 and D7 are already set to low, so we don't have to change them. Click on Code to hide the coding space. Then click on Start Simulation and you can see the LEDs will turn on and off in a beautiful pattern. First LED 1 turns on, then the second LED turns on, and then the third LED turns on. Now LED 1 turns off, LED 2 turns off, and finally LED 3 turns off. Click on Stop Simulation. These codes are executed in a loop, so the microcontroller keeps on running these codes repeatedly. I hope it's clear to you. Similarly, by changing the code, you can also create wonderful patterns of your choice. You can try a small activity on your own. You can add more LEDs and try different color patterns of your choice. Try it out yourself and explore more. Practicing this will surely help you to do more circuits just like this. In today's session, we learned about the different conditions to turn the LED off so that we could make them blink. We saw that the LED turns on and off in a fraction of milliseconds, which the human eye is not able to capture. So we introduced wait 1 sec block to give enough time for the LEDs to turn on and off. We then also created beautiful color patterns for 3 LEDs just like in serial bulbs. But there is a limitation in the number of LEDs that can be connected to the Arduino. So in the next session, let's overcome all these difficulties. So just remember one thing. The difference between ordinary and extraordinary is practice. So practice all that you have learned and I will meet you in the next session. Until then, bye.